not correcting you, just weird things.
We're a middle school.
I mean, I work with high school kids now, and they're like, I'm a show choir team director at Help.
All right, guys, let's take a look here. Does anyone have a vote for which problem was the hardest one? If you had to pick. So if you say yes, these are the whole thing. No. Is there one that really gave you the most trouble, or that you forgot, or no? Or you're all like, they're all about equal? Yes? No? Maybe? Okay? Yes?
I don't even remember F. One F that is just gone from my brain.
Oh, this guy.
Yeah.
Understood.
Yeah.
Right, so we'll definitely talk about him.
Everything.
We're gonna talk about all of them, but I'm just curious if any of them really were like, what the hell?
No.
Okay. What's the idea on part A? Yeah, in fact, PEMDAS is everywhere, correct? PEMDAS is like the grammar of math, and does anyone know more than one language? Anyone ever learned another language? Anyone ever start to learn it, like you don't speak it fluently? Yes, okay. One of the hardest things about learning another language, the vocab you can just kind of memorize. The grammar, like what order do you do things in and so forth. Do you say white house or house white, right? That kind of thing. The grammar, so that's why order operations is kind of difficult, because it's like the grammar of math, right? What does PEMDAS mean? What's the saying? Anybody remember the saying to remember it? Please excuse my dumbass son. That's right. That's what I use. 1 year, my class came up with this, by the way. Please excuse my deficient algebra skills. So they created that. I just want to make that really clear. I wasn't me going. Anyway, no matter what the hell you call it, we all know how to say it. PEMDAS, right? So here's the thing. You see it like this. Okay. Right? PEMDAS. It could have easily have been this. Which one's easier to say? If you say the second one, you sound drunk. Right? Ted Mercer. Right? Lost the first, not me. It's an order operation. Okay. You guys all with me a little bit? Okay, I like it. So the way I like to write it is like this, because I'm freaking weird. So what this means is definitely parentheses first, then definitely exponents next, then either one of these as they come, and either one of these as they come. So go with me for a second. Let me blow your mind a little bit. Division does not exist. What the shit, Joe? There is no spoon. No. Division is just multiplication by the reciprocal of something. Yes? That's why multiplication and division are the same equal importance. So you don't do one before the other one if they're in a row. You just do them as they come. I have seen with my own eyes teachers teaching that you do multiplication first, and they need to stop. They just need to get a different job. It's going to drive me crazy. Anybody still like on the Facebooks, on the internets? Sorry, I'll stop doing that. Anybody who look at Facebook ever? No? Yes? Sometimes you'll even see this on the TikToks and the Instagrams. You'll see a stupid post saying, what's this math? 3 minus 2, and you get all these people, it's 1, it's 16, it's 4. I'm like, oh my God, help me. So anything that's multiplication, division, you do it as it comes. Anything that's addition, subtraction, you do it as it comes. What does that mean? Let's look at this problem. See this here? Let me ask you this, let me make it really clear. What's another way to write 8 divided by 3? You can write 8 over 3, correct? What's the only number there that would go on the bottom? 3. Are you guys with me? That's the only number that's being divided. If you make that 12, all of a sudden you got 12 on the bottom. You've changed the problem. You guys see that? Do you guys see that? All right, so let's work through this. What's the very first thing I have to do? Parentheses. So what's 5 minus 2? Holy shit. Okay. What do I do next? Exponent. So what's 3 squared? 9. Crazy. The next thing I do now, from the very beginning, I knew what the last thing I was going to do. From the very beginning, what was the last thing I'm going to do? Subtraction, because it's at the ass end of PEMDAS. Stupid joke, I don't care. I like it. Right. So I know I'm going to do this thing last. So this is all division multiplication. You do it as it comes. What's 9 divided by 3? 3. And what's 3 times 4? 12. And what's 7 minus 12? -5. And if you have any trouble with negatives and all that kind of stuff, think about it as money. If I got $7, but I owe you 12, I give you all my money, I still owe you 5. Right? Just in case, you know, sometimes people still have trouble with different sign numbers and putting them together. All right, how we all doing so far? Good old PEMDAS. It's always there. What about part B? What's the very first thing you should do there? There's actually a couple answers I would take here, but yes. I like it, and I heard somebody say they did it and they forgot the name of it. Does anyone know what that's called? Yeah, distributive property. So you gotta love it. Sometimes math people, we are not the best at naming things very often. I'm not sure if you guys have noticed this. But distributive property, we actually got that pretty good because that's what you're doing. You're distributing it to everything, right? So what's -2? Let me see, 3a minus 5b plus 10b. What is -2 times b?
-2b.
Great. And what's -2 times -5a? Positive 10a. Is everybody cool with that? Is that all right? Why do 2 negatives make a positive when you multiply them? Does anyone know? So I like to think of negative as turn around. So if somebody told me turn around, and then it said turn around again, aren't I facing the same way I was? So those 2 turnarounds canceled out. So if I see 2 negatives multiplying each other, they're going to cancel each other out, like 2 turnarounds would cancel each other out. Maybe. All right. Some of you guys I would never play poker with. You've got an awesome poker face. I'm not going to give you any sign of how I feel about what you just said. So now what's the name of the game? Who knows what the name of what we're about to do is? Combining like terms, kick ass. So what can I put together with the 3a? By the way, this is my writing. So if you wanted to choose a teacher, you could read the writing. If you've chosen poorly, I'm sorry. But I'll try to do better. Yeah, I'm out of practice. So I combine 3a with what? 10a. And you get, holy crap. And then what about the b's? I get -5b plus 10b. What's that so far? 5b minus 2b plus 3. Is that cool? Okay. Not too bad, not too shabby. Now, real quick, I understand, again, if a lot of people around you are going, I get that, and you're like, I don't get that. Ask, trust me. If you have a question, at least 5 other people have that same question. And all of you are just being quiet, so you could be their hero, if just for one day. Okay. Now this problem, I didn't say what you should do, but what do you always do with the fraction at the end? You see if you can simplify it, reduce it. Real quick, I want to show you something kind of cool. What's the difference between those? How far apart is 36 from 54? 18. The only numbers that could possibly reduce those, that you could divide by, are 18 or factors of 18. Does 18 go into both of those? Does 18 go into 36? Yeah. Now, based on that answer, I really want you guys with me. 18 goes into 36, correct? 54 is 18 above 36, so doesn't 18 have to go into 54 also? Right? If 18 goes into 36 twice, 54 is 1 more 18 up, 18 goes into 54 3 times. So that's 2/3. Now, do you have to do that? No, you could just do this. I don't know if anybody did this. Divided by 2, 18 over 27. Divided by 3, 6 over 9. Divided by 3, 2/3, right? You can, nothing wrong with that. Step by step, yes?
I don't know if this was just a coincidence or this is another way you can do it, but if you just notice that 36 is just six times, could you just...
Oh yeah, totally. No, so you divide it by 6 first then, right?
Yeah.
So yeah, you could divide by whatever you happen to see works, and then you just check to see if you're done, and you just keep dividing until you can't, right? You guys with me? A little bit? Okay. Real quick, I want to introduce an idea. Is this in, you can do it, Jeff. Can you? Is this in lowest terms? 8 over 27, just for example. Yes, good, right? But 8 and 27, they're not prime numbers, correct? What is a prime number?
Like,
What?
it can't be divided at all.
Yeah, you can only divide it as
easily.
1 times itself.
Yeah.
So for example, 7, you can't break that up into nice whole numbers except for a 1 times 7, correct? Neither one of those is prime, you all with me? Because 8's 4 times 2 and 27 9 times 3. But they are what's called relatively prime. They are relatively prime with each other because they share nothing except 1 with each other. Does that sort of make sense, that idea of relatively prime? I don't know why I decided to tell you that just right now, but it just came to mind. Okay. All right. That was just a little something. So 2/3 is the right answer. What about this one? I talked to one group a little bit about one way to do this. One way you can do it. Did anybody do this problem and feel like they got it right? Yes, what'd you do? So you made it into an improper fraction? No? Did you do like 7 times 5 plus 2? No. So tell me again. Oh, you multiply 5 times 2. I got you. Okay, so.
They're the same number from the bottom. And from what I've seen is that if it's from the same number at the bottom, then you just divide the top with the.
Okay, so I'm not sure if this is related to what you're saying, but this is one of the most unfortunate decisions in mathematics. Some of you guys might say, well, the whole thing was unfortunate, but one of the most unfortunate decisions in math, because, for example, what does this mean? 2x. What's the operation between 2 and x? If they're sitting next to each other. Multiplication, right? So some people might think then, well, this is sitting next to each other, isn't that times? No. What is it really?
Remainder.
Well, yeah, I mean, all right. Look at me, you're okay. That's one way you can write a remainder, but that doesn't tell me the operation between these two numbers, right? Addition. You guys understand that? This is 5 and 2 sevenths. So isn't this 2 sevenths above 5? So it's 5 plus 2 sevenths. So it's really dumb. At some point in history, some math people said, let's just put them next to you. You know, God. Because we drill it into people's heads. If it's sitting next to each other, that's multiply, except for this time. And he's like, what? It's like I before E, except almost ever. No, I before E, except after C. That's a bullshit thing, yes? Okay. So, one way to do this problem is to convert both of these things into what's called improper fractions. Anybody remember what this sucker's called? It's got a whole number part and a fractional part. It's called a mixed number. Because it's got a whole part and a fractional part, right? So I can convert these into improper fractions. Improper just means the top is bigger than the bottom. You guys all with me, sort of? And again, real quick, I just want to really point this out. Today is review. Today, not really even a review. It's just sort of like going over some stuff that you might have seen in your past. After today, you're not supposed to suddenly know how to do all problems like this. Do you hear me? I'm not, no, we told you about it, you should know. No, that's crap. I'm trying to lay some groundwork. We're going to hit all this stuff again in different chapters. I'm just trying to lay a little bit of groundwork. You with me? So don't go away thinking, I don't know all that stuff. I'm going to drop. No. You're going to be okay. So let me see if this sounds familiar, and then I'll explain to you why it works. 7 times 5 is 35 plus 2 is 37. Does that sound familiar to anybody? That's how to convert from a mixed number to an improper. Now let me ask you, does anyone know why that works? Yes?
So the 5 is like 7 over 7 5 times.
Okay, I like it.
Yeah, because since it's a whole number, in order to make a fraction over 7, a whole number is 7 over 7.
Kick out. So real quick, the 5 is currently over 1, right?
Yeah.
So to make like denominators, you'll have to multiply top and bottom by 7. So don't you multiply 5 times 7 to make the same denominator? And that works out, denominator. So the shortcut then is 7 times 5 is 35 plus 2 is 37 over 7. So that's the shortcut. So that's all it is a shortcut. Then if you do the same thing to the other dude, 7 times 2, 14 plus 4? 18. Now you can do this easy, right? What's that? 19 over 7. Can somebody make that into an a mixed number?
2 and 5 7.
Yeah, so a quick way to do that, 19 sucks over 7, because 7 doesn't go into 19 evenly, right? What's the number below 19 that we wish was up here? 14. So let me show you real quick. So this is 14 sevens plus 5 sevens extra, right? So this is 2 and 5 sevens. Okay, maybe. Let me show you a different way to do this problem. Not a damn thing wrong with this way. Nothing wrong with this way. I'm just going to show you a different way, right? In fact, remind me, if you had to do, let's say, this problem, you could do it, Jeff. This problem by hand, what would it involve? What would you have to do?
Borrow.
You have to borrow a couple times, right? You have to borrow from this poor guy, and then you have to borrow from this poor guy, and then you can subtract, right? Because the whole problem is the number on the top is smaller than the number that's going to be subtracted, right? I could do something very similar here. Let me ask you guys, is 1 equal to 2 divided by 2? Is 1 equal to 2 divided by 2? Yes. Is 1 equal to 7 divided by 7? Yes. So, if I take a 1 away from the 5, so it's 4 now, right? You with me? I can add that 1 to the 2 sevens. And we just said 1 is equal to 7 over 7, so I can add 7 over 7. So it'll become 4 and 9 sevens minus 2 and 4 sevens. 4 minus 2 is 2, 9 minus 4 is 5. Same answer, quicker. Maybe? I love you guys so much. So again, let me do that a little bit bigger. That's kind of small. Heavier paper. I'm going to do it again. Do it live. Let me see, 5 and 2 sevens. Make it really big. Minus, what was it, 2 and 4 sevens? Okay. So I'm going to take 1 away from this. So can't I add 1 then to this piece? Because I have an extra 1 floating around? Isn't 1 7 over 7? So this becomes 4 and 9 sevens. Now, dear God, does this number make sense? I mean, is that number written correctly? No. But neither is, I love you guys, you're all like, good Lord, dude. Neither is this freaking number. What number is that? It's not a number, it's just work, right? We're in the middle of working something out. It doesn't have to be a number that makes sense. It's just the parts make sense. Same thing here. This is not a number I would ever accept as an answer, but right now I'm not at the answer yet. I'm in the middle of work. So then you can get 2 and 5 sevens. Okay. Everybody sort of with me? Now again, 2 ways, 2 methods, both equally valid. I like it. Okay. Let me say this while I'm thinking about it. One of the worst things that an elementary teacher or an early school teacher can do to a student with math is to not be flexible with what they're trying to do. Can any of you attest to this? Did you ever have, you did something a different way, you got the right answer, and your teacher just went, you did that wrong, it's not what I showed you? That's complete bullshit. Because that poor student's going to be like, I thought I understood this, I got the right answer, it was wrong, screw math, right? I mean, that's the progression. Maybe not that quick, but that's basically where it's going to go. Are you guys kind of with me? You need to meet the student where they're at and say, okay, I see what you're trying to do. It actually works in this case. And then if it doesn't work in general, or if it's, very often I have a certain way I teach things because it helps them later. So I like to tell people, okay, the way you did it works, but later I want you to practice with this other way because that other way is going to work better. You guys, so give the student the complete picture of why their way is currently not good, or be more flexible and go, that way is beautiful. Right? I mean, do you understand what I'm saying? Okay. All right. Hey. No? Okay. What time is it? He's like monster.
1:56.
He's excited about his next class. All right. What about part E? How does that work? What do we need to get before we can do anything? Is the answer 6 over 6? If anybody got 6 over 6, then don't say anything. Just keep interested. Right, why is it not 6 over 6? Real quick. One thing I like to talk to you about is how to interpret mistakes students make. What did I make? If my answer is 6 over 6 equal to 1, what mistake did I make? It's pretty obvious here, right? Yes?
You didn't have a common denominator, so.
Yeah, I didn't get a comment on that one. And I just
Yeah, you just
subtracted across, right? It's one of the hardest things for a student to understand because I know what 18 minus 12 is. And isn't that what that's saying? No, it isn't. In fact, do you guys understand why this problem works the way it does? Because can you do, can you guys tell me, what's 11x minus 5x? 6x, right? What's 11x minus 5y?
11x minus 5y.
You can't do shit with it, right? Isn't this 11 eighteenths, 11x, 11 eighteenths, minus 5 twelfths, 5y. They're 11 of these minus 5 of those. That's why you can't do it the way it's written. Now these are numbers, not letters, so we can actually do more. I can't do anything with x I can't erase it, make it, now it's a y. No. But with numbers, I could do shit, yes? Okay, I really want that understood, because that's what students don't get. They're like, why are things different? And I try to tell my students when I'm teaching class, if you feel like things are different, come see me, because it can't be different. We're just learning new stuff. Old stuff can't suddenly be wrong. We're just adding, correct? You guys kind of, okay. So help me out, I'm sorry. You have to find what now? Common denominator, okay. And this one's not that hard to do, right? Because I'll take the bigger one and start making multiples. I don't know what ways you guys do it. Does anybody have a certain way they find common denominator? No? You guys are like, whatever hits me at the moment, Jeff, all right? How did you guys find the common denominator in this case?
I just looked for what's the closest number that they can both multiply into.
Okay. And did you do something similar?
Oh, I thought it was 6, and then found something that I think about going to at 36.
Oh, okay. All right, so you kind of went down and then up, and really should just go up, right? Yeah. But you eventually got to what they can both go into. Yes?
I just take the bigger number and I double that, and then see if the other number can go into that.
Got you. And if it doesn't, then you triple it, right? And just kind of keep going with multiples. I love it. All right. Let me show you something, because sometimes the bottoms get gross, and that would take forever, right? If this is 117 and this was 58, do you want to do that? I don't either. So let me show you. This is kind of cool. What number do they both, like you already answered this question. What number do they both have in common? 6. 18 is 6 times what? 12 is 6 times. Do you see now how the first dude, what is the bottom missing that the other guy has? They both have a 6, correct? What is this guy's bottom missing that this guy's bottom has? A 2. Do you guys see that? He's missing a 2. This guy's got a 2, he doesn't. What is this guy missing that this guy's got? 3. So then you just give them each what they're missing. Yes? Now real quick, I didn't have to do that way for this problem, because this problem is relatively easy. You double 18, 36, 12 goes to the 36. I'm done, Jeff. But I'm just trying to show you a more general way. This is kind of cool. What do they both have in common? Break them out like that. Then you can see exactly what they're each missing. So if I double this guy and I triple this guy, I do get 36, right? Okay, maybe. So of course, I always get somebody who does this. What has this person done wrong? Shit. Exactly. So I've got a triple, I've got a double. So this better be 22. I might as well just rewrite it. 22, and this will be 15. So then I end up with 7 over 36, and you can't reduce that, so you're done. I love it. Okay. I like it. Just to remind you guys, real quick, going back to the earlier thing I said about a lot of different backgrounds, if we're ever doing something that's really easy, enjoy that time. Just sit there and enjoy it, right? Because somebody else might be having trouble with it. So I always like to say, if I'm going too fast, slow me down. If I'm going too slow, deal with it. What about, oh yeah, this is somebody's favorite one, right? So, there's several things happening in this problem. There's division of fractions, which is somehow based on multiplication of fractions. And I don't know if you guys remember how that relates and why. Does anyone know what to do in this case when you have division of fractions?
Copy dot flip.
Interesting, copy dot flip. So you just reciprocate the second dude, right? And then you multiply. Is everybody with me on that? Some of you guys with me on that. Some of you guys are like, I don't remember what the hell. Fractions, no. But if you have division of two fractions, you multiply by the reciprocal of the second dude. Does anyone know why you do that? Oh, I thought you might. Hold on to it. Sorry, Ron. Yes.
I know you said earlier that division was just the reciprocal.
Yes.
So if you do the reciprocal.
Exactly.
Reciprocal again, it's like.
No, well, here we just reciprocate once and then it becomes multiplication.
Yeah.
But right now I'm asking, why is that true? So let me show you. Let me do a simpler problem, I think, real quick, just to make this simpler. So let's say we had 3/5 divided by 2 7s, right? Now go with me. I'm about to show you something that if you ever did it, I would look at you weird. But I'm showing it to you just to prove something, correct? You're all with me. I'm not saying ever do what I'm about to do. You would never do it this way. I'm just showing you why the shortcut works. You guys all with me? I don't want somebody out there going, why are you making this so hard? No. I'm just showing you why the shortcut works. Because multiplying by the reciprocal is a shortcut. We just don't even know that. So I'm about to do something you would never do. What's another way to write division? Isn't it this thing divided by this thing? Is anybody already really excited about this? So this is, this is like the Oreo double stuff. This is fracception, right? This is fractions inside of a fraction. Are you with me? So, go, Jeff. Good job, math boy. It looks worse now. Thank you. But watch this. Why does this suck so bad? Because it's a fraction on top and on the bottom, correct? Can somebody tell me what is the absolute best number to have in the denominator? 1. 1 is the kick-ass number in the denominator, correct? What do I multiply this by to make it 1?
2 over 7.
7 2.
7 over 2. If I multiply the bottom of a fraction, don't I have to multiply the top also? Right? If you double the top, you got to double the bottom. We just did that, didn't we? So why am I multiplying by 7 over 2? Because it makes the bottom the best it could be. I have to multiply the top by the same thing to make it all legal, correct? What does this become again? 1. So what does this equal? The multiplication of the reciprocal. I don't know, this is, the crowd goes, what? I just proved that, sorry, you can't see the whole thing, that the division of two fractions is the multiplication of the reciprocal of the second guy. Should be a big old times. Okay. And then, of course, the boring part of this is what the answer is. So coming back to this. No. Coming back to this. How do I immediately rewrite this? No. I leave the first guy alone, and I multiply by the reciprocal of the second guy.
20 over 21.
Now, dear God, do not do 14 times 20, 280. Don't do 25 times 21. It's whatever the hell that is, right? Does anyone know what you can do now to make the numbers smaller? I'll go ahead and let you go.
Or get like all the common denominators, or not
Common factors,
common
right?
factors.
So like, does anything go into both 14 and 21?
7.
So I can reduce this diagonally if I want to, because all these are on the top, all these are on the bottom, so anything top and bottom that's the same cancels. So I can divide by 7 here, 2, 3, what can I divide here? 5. Then I multiply. 2 times 4, 5 times 3. Maybe? So dividing fractions, you multiply by the reciprocal. I showed you why that's true. But then when you're multiplying fractions, you can just reduce the numbers before you do anything. You get smaller numbers, that kicks ass. Okay. All right, maybe? Then we start to step into something that sounds suspiciously like a word problem, but not quite fully yet. 2A is so something else about learning a different language is the order of things. So 2A, English, I don't know if you guys know this, English sucks. If you knew a language first and then you learned English, you're like, what are you people doing? I grew up here, so I learned English primarily. I like to say English is my second language after math, but that's not really true. But right, so if you learn it, you're like, what's wrong with everybody else? But everybody else in the world is like, you people are crazy. Anyway, English has a very strange problem with this word less, right? So for example, somebody tell me, what is 7 less than 10? What number is 7 less than 10? Did you do 7 minus 10? Nope, you did 10 minus 7. So how do you write 5 less than 2? 2 minus 5, 11. So English has a problem. English has many problems, but one of them is, in this case, it's not the math's fault, it's the English that's weird. Math goes, oh, you mean this. Now what is 2 minus 5? Negative 3. Okay. What about this one? 3 more than the product of 7 and 5. What the shit does product mean? Multiply. 11. What's the word for division? The proper word. I'll tell you this, it starts with a Q.
Q?
Yes. Quotient. Kick ass. Right? And that's one of the ones we always forget. We're like, dude, it's just divide. Leave it alone. Okay. So you got product for multiplication, quotient for division. This is product. So how do I write an expression that means the same as this, but in Mathish? I'm translating from English to Mathish. 3 more than the product of 7 and 5. How do I write that? Second. 7 times 5 plus 3. Kick ass. And then what's that answer? 38. So you get 35 plus 3, 38. Jeff, 2. It's getting warm in here. Is this true? Feels warm to me. Okay.
Could you write this as 3 plus and then parentheses 7 times 5? Would that still be right? Because then you just do the parentheses.
Sorry? Say again?
Like if you wrote it 3 plus 7 times 5 in parentheses.
Sure.
That would still
That's what we
be
call
like
unnecessary
right.
parentheses,
Okay.
but so it doesn't change the meaning, so you can
Okay.
put them in there if you want to. Does that make sense?
Mhm.
Yeah, okay. So I wouldn't take points off if you wrote that down, it's just
Okay.
not really necessary. Okay. What about number 3? Did this bring back any flashbacks for anybody? Yeah, sorry. So, but again, the same idea up here. Your eye should be drawn to distribution whenever you're simplifying or solving. So the very first thing to do this whole thing is distribute. So what do I get? I get 4x minus 2 equals 5x minus 3. Yeah, you pick a side for the x's, and you pick a side for the numbers. Done. And then how do you check that? You just put 1 back in. So what this means is this equation is true when this is true. So if you plug it in, it's got to come out to be true. Okay, all right, such an exciting day. We did syllabus, we did math, and we're still not done. Sorry, I made it sound like I am going to let us out a little early, just not this early, right? I think, what are we done? Oh, no, we're done at 2:20, right?
Yeah.
Okay, I'm sorry. My other class is done at 2:35. I think I will let us out now. Why the hell not? Does that sound all right? Anybody upset about that? I'm sorry if I'm taking 10 minutes away. I paid for this time. I've had somebody tell me that.
Really?
So, yes, and I told them,
Wait,
oh
what did they
well,
say?
report me. Huh?
What did they say?
They were upset that I let them out early, like 10 minutes.
Couldn't be me.
And I was like, oh well, go watch my videos. Anyway, sorry. All right, guys. If anybody needs to see me for some reason, come up. Otherwise, I will see you Thursday, and we'll take a field trip on Thursday. Thank you.
Next week, see you Thursday.
Yeah, I forgot to say, chapter 1 is sort of like a word problem section. So I kind of want to get us to 2 and ease us in. It was chapter 1. The first time I taught this course, I did chapter 1 first, and really everybody was really not correct. I said 4. Anyway, so that's long, short. Yeah. Let me grab this. I'm still recording.